Hey GED students, it's GED question of the daytime. This problem says match each expression on the left, so we've got some expressions on the left, to an equivalent expression on the right. Equivalent meaning equal. So for each expression, mathematical statement on the left, we've got another one on the right that's equivalent, that's equal to it. And I'm going to say right now, if you haven't yet, I suggest you, if you haven't seen it yet, I suggest you stop this video and go watch the equivalent expressions video that I did before this, the very one before this, because this is going to build on those concepts, okay? And this one's just a little trickier because students panic when they see letters. The last one only had numbers involved. So let's take a look. Let's look at what A says. So what A says here is x plus x plus x. Now, a lot of students struggle once we get to algebra with the letters, starts in the idea of simplifying. And so if that's you, replace that letter with a number in order just to think about it. So I'm going to think about this being like 7 plus 7 plus 7. So 7 plus 7 plus 7. Yes, I could just add up the sevens, but you can also think about this another way. We know that when we are repeatedly adding the same number, in this case 7 plus 7 plus 7, we added the number 7 3 times. There's another way you could write this expression. You could write this as 3 times 7, 3 sevens. Okay, so adding 7 3 times is the same as multiplying 7 times 3. And so we can make that generalization that we make with numbers to letters as well. If you have x plus x plus x, well, that's adding an x 3 times. So that's 3 times x, or 3 x's. So x plus x, A, matches with 4, 3 times x. Great, now let's take a look at B. B is similar, but instead of seeing repeated addition, what do we see? We see x times x times x. 3x's multiplying. 3x's multiplying, and I hope you guys know by now you're familiar with the concept of exponents. When mathematicians want to be lazy and shortcut talk about repeated multiplication, the same number, in this case x, multiplying over and over again, they use exponents. So this is x multiplying by itself how many times? 1, 2, 3 times. That's the same as x to the third power, or x cubed. So x times x is the same as x cubed. B matches with 1. Looking at C, notice what C says. C says 2 times the quantity of x plus 1. 2 times the quantity. I want you guys to hearken back to what 2 times anything means. Like, let's do it with a really simple number. Like, let's think about 2 times 5. What does it mean to have 2 times 5? Well, it means you have 2 5s adding. And that's the same as saying like 5 plus 5. 2 times 5 is 10. 5 plus 5 is 10. There are 2 ways to talk about the same thing. So similarly, even though it's big and ugly, if I talk about 2x plus 1s, that means I have 2 of this whole dang thing, x plus 1 adding. So you have, there's one x plus 1, and that's going to get added with another x plus 1. 2 times the quantity can also be thought as 2 x plus 1s adding. Oh, whoops. So that means C, 2 times x plus 1, is the same as 3x plus 1 plus x plus 1. Okay, now let's look at D. D says x plus 1 squared. Well, we just talked about what those little floating numbers mean, those exponents. What do they mean? They mean repeated multiplication. So what am I saying? If I say take all of this, x plus 1, and square it, I'm saying take all of this and multiply it by itself 2 times. So I'm going to take x plus 1, and I want to multiply that whole thing with another x plus 1. When mathematicians want to just multiply big ugly numbers, they enclose each one of the big ugly numbers in parentheses, shove those parentheses right up close to each other, and that says x plus 1 times x plus 1. So D matches with 2. Let's recap. So then A matched with 4, B matched with 1, C matched with 3, and D matched with 2. I keep doing that. 2. Now, I know this is a complex problem. I know a lot of students find it intimidating, but you can do this too. We can use this kind of mathematical reasoning. This is really what we need to be successful in algebra. Great. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.